Good day everyone, I am Tim Murkomen, IT security, architect and DevSecOps practitioner. Today I want to talk about something I strongly believe in, which is security. That security is not a face, security is not a tool, security is not a department, security is an architecture. So in other words, we are saying that if security is not embedded at design time, it becomes an emergency later on. So today we are talking about building systems that are highly secure by design, secure by default, and secure at scale. Why this conversion really matters. So let me start with this, that security can no longer be the gate at the end. Over 70% of modern breaches actually originate from the application layer, not the firewall, not the data center, and not the application. Cloud native architectures as well have really multiplied our attack surface. Things like microservices, APIs, containers, serverless, third-party libraries, we deploy multiple times each and every day, and attackers are continuously attacking. And here is the truth. If you automate delivery but don't automate security, you automate vulnerability deployment. So speed without security is simply the fastest risk ever. So traditional security models are too slow for modern engineering, and that's why DevSecOps is no longer optional. It is currently a survival. Now let's check the difference between DevOps and DevSecOps. Traditional DevOps majorly focused on speed, which was very necessary, but security became the bottleneck at the end because of things like manual reviews, the last-minute scans, emergency patching. So DevSecOps changed the mindset, and here security starts at day one, and security checks are always automated, and risk is continuously reduced. And most importantly, security becomes everyone's responsibility. That means it's a shared responsibility, not just the security team. That cultural shift is the real transformation in DevSecOps. Now, we want to understand what DevSecOps really means. DevSecOps is the integration of automated security controls across the entire software development lifecycle. It is not generally bolded, or it is integrated, in other words. So the core principles of this DevSecOps is shift left. Shift left, in other words, we mean that we try to locate or find vulnerabilities before they reach production. And then there is also another concept of automation first, where humans cannot manually scale security. We have another aspect of continuous monitoring, and here we are talking about security. In other words, security doesn't end at deployment. Infrastructure as code on the other side, here we must be version controlled and scan. That is from the infrastructural perspective. Then we majorly focus on policy as code, where governance must be enforceable and not documented in PDFs. And finally, security is a shared responsibility. If developers can push code, they can, or in other words, they must understand security. If DevOps can deploy infrastructure, they must understand secure configurations. So security is engineering. Now, the whole model looked like this. You develop first of all, then you do the testing, you deploy, then you call security. And by that point, when you are calling security, it is too late. So fixing vulnerabilities in production is very expensive, both from the financial perspective and also the reputational damage. So instead, we redesign the flow. Design with threat modeling, write a secure code, you run the automated security tests in the CI, that is continuous integration. You validate infrastructure before deployment. So security must move upstream. And we normally say that prevention is cheaper than remediation, always. I think that is the concept of major security engineers out here. Prevention is cheaper than remediation, always. Yes, now this CI/CD must become CI/CD/CS. In other words, we are saying it must become continuous integration, continuous delivery, and continuous security, and security must be embedded at each and every stage. At the coding stage, we do static analysis, that is secret scanning and linting. At build stage, we do more of dependency scanning and software bill of materials generation. At this stage, we also do more of dynamic testing and API security testing. At container stage, we do image scanning and phase validation. At deployment, that is infrastructure as code, we do more of scanning as well, and also policy enforcement. At runtime, we monitor endpoints, and also at the same time, we do more of anomaly detection. So security here is not a single gate, it is continuous, and it is continuous pressure against the risk. Now let's mention something about SAST, DAST, and SCA. SAST, which normally checks on your code before it runs, normally checks on insecure coding patterns and stage vulnerability detection. Then when we talk of DAST, on the other side, attacks your application while it is executing or while it is running. It tests or simulates read attacks and detects runtime vulnerabilities. Then we have software composition analysis. This one checks third-party dependencies and detects most common vulnerabilities. So the truth here is, or the uncomfortable truth here is, most breaches today are not 0 days. That means it does not occur in 0 days. So they are known vulnerabilities sitting inside outdated dependencies, and most people nowadays adopt open source, which is very, very powerful. But unmanaged open source can be very dangerous. If you are not scanning your dependencies automatically, then you are operating blind. Now let's talk where we talk of policy as code, PAC, and this is where advanced organizations separate themselves. Policy as code, in other words, means security rules are executable. If someone commits a secret, the pipeline blocks it. If infrastructure violates compliance, deployment definitely fails. And if a dependency exceeds risk threshold, then the build stops it. There is no enemy, no email, no any argument. The pipeline enforces policy consistently, and this consistency in security is highest level of maturity. When security becomes programmable, it becomes more scalable. Now, metrics that matter. Here we're talking to senior management and maybe the key leaders, or how global leaders measure DevSecOps maturity. And security always must be measurable. If you cannot measure it, then you cannot approve it. We track things like mean time to detect, the mean time to remediate, vulnerability density, or talk of things like secure deployment frequency, the percentage of automated security scans. We talk of things like policy violation rates. These metrics show whether security is reactive or engineered, because DevSecOps is not about feeling secure, it's about proving it. Now, DevSecOps maturity model. So organizations evolve in various levels. Level 1 is where manual security testing, they do their testing manually. We have level 2, which focuses on automated scanning. We have level 3, which is more of integrated security pipelines. Level 4 is more of policy as code and infrastructure as code scanning. Then finally, level 5 is where they do more of predictive AI-driven automation. So this transition, or the transition, is from compliance-driven security to engineering-driven security. And compliance asks, are we passing these audits? Then engineering asks, are we reducing risk continuously? So the second question builds resilient organizations, which is very key to global leaders, especially in DevSecOps domain. So DevSecOps is not a tool. You cannot buy DevSecOps. It is not a team sitting in a corner. It is not a checklist of auditors. In other words, DevSecOps is a culture. It's a design philosophy. It's a competitive advantage. Organizations that embed security early move very fast, not slower, because they don't pause for crisis response. They build confidence into their releases, and they also have confidence in innovation as well. Now, let me conclude by saying that if security is embedded early, then it is innovation protected. And DevSecOps is not about slowing developers down. It's about enabling them to move fast and also safely. We are building systems that power economies, financial systems, healthcare, AI platforms, national infrastructure, and security cannot be optional. Secure by design, secure by default, and secure at scale. Thank you so much. Bye.